And this is the second part of our discussion on Pascal's triangle and the binomial theorem. Now, if you'll remember, of course, here's our Pascal's triangle, at least up to 5. And then the binomial theorem says that every term in a binomial expansion follows this pattern. Remember that it's C, it's NCR, and then the first variable, x to the n minus r power, y to the r power. Now, this is based on your binomial being x plus y to the n. All right, so every term is going to follow this pattern right here. So we're going to use the binomial theorem to expand our little tricky binomial here. So, first of all, for this binomial, n is 5, and my x is 2a squared, and my y is negative square root of 3. So when I start this off, then my first term is c, and then 5. So 5c, 0. You always start with the first term, r being 0. And then x is 2a squared, so I've got 2a squared to the 5 minus 0. And then my y is negative square root of 3. And it's to the r power, and so that's 0. All right. My second term is 5c1, and my x is 2a squared. And then n minus r this time is 5 minus 1. 5 minus 1. And then my y is negative square root of 3. Remember, the negative sign goes in the parentheses with the square root of 3. And r is 1. And then my third term, 5c2. And then my x is 2a squared. 5 minus 2 would be its exponent. And then the negative square root of 3 has an exponent of 2. Okay. And then my next term is 5c3, 2a squared, to the 5 minus 1, or sorry, 5 minus 3, and then negative square root of 3 to the third power. And then, we're kind of out of room down there, so plus 5c4, and then 2a squared to the 5 minus 4, and then negative square root of 3 to the 4. And then my last term is 5c5, 2a squared to the 5 minus 5, well, and negative square root of 3 to the 5th. So those are all of the terms in the binomial expansion. I'm going to draw a line right here just so that we can kind of keep straight where we are. So we're going to simplify this. Now, C5, C0. Since I have my Pascal's triangle written here, I know that C5, C0 is 1. So I can just go down the line, and these are all of my C's. All right? So C5, C0 is 1. So we're going to put 1. And then 2a squared to the 5th. Well, 2 to the 5th is 32. So that's 32. And then a squared to the 5th is a to the 10th. Negative square root of 3 to the 0 is just 1. So this is the first term. The second term has a coefficient of 5. That's my C51. Okay. So coefficient of 5. And then 2a squared to the 5 minus 1, which is 4. So 2 to the 4th is 16. A squared to the 4th is a to the 8. And this time we have negative square root of 3 tacked on. All right, here's the next term. 5c2 is 10. And then 2a squared to the 3rd power. So 2 to the 3rd is 8. A squared to the 3rd is a to the 6th. And then negative square root of 3 squared is just 3. And then my next one's 5c3 is also 10. So 10. And then 2a squared to the 2nd. Well, 2 squared is 4. And a squared to the 2nd is a to the 4th. And then negative square root of 3 to the 3rd. Well, negative square root of 3 squared was 3. And then I just tack on an extra negative square root of 3. So this is negative 3 square root of 3. And then plus C5, 4, or 5C4 is 5. And 2a squared to the first power. Well, that's just 2a squared. And then negative square root of 3 to the fourth. Well, that's like 2 negative square root of 3 squared. So negative square root of 3 squared was just 3. So I've got 2 of those. So 3 times 3 is 9. And then my last term, the coefficient is 1. See, 5C5 is 1. And then 2a squared to the 0. Well, that's just 1. And then we have negative square root of 3 to the 5th power. Well, that's going to be our 9, which was negative square root of 3 to the 4th power, times one more negative square root of 3. All right, so now all we have to do is simplify this. So this is 32 A10. And then 5 times 16 is 80. But we've got this negative square root of 3. So I've got minus 80 square root of 3, a to the 8. And then here, 8 times 3 is 24. 24 times 10 is 240. So plus 240, a to the 6. Then this is 4 times negative 3, which is negative 12 times 10, negative 120, with the square root of 3 tacked onto it. And then a to the 4th. And then 5 times 9 is 45, or 5 times 2, 10. 10 times 9 is 90. And then a squared. So we've got plus 90 a squared. And then the last one is minus 9 square root of 3. And this is my answer to the expansion of that. That was a whole lot easier to get than multiplying that out using your distributive property. Now, one more quick thing. Let's suppose that we want to find the coefficient, just abbreviate that, we want to find the coefficient of h to the 14th power in this expression in the binomial expansion of 2 minus h squared to the 15th. All right, if we want to find the coefficient of the term that has h to the 14th in it, then the first thing I want to look at is h to the 14th. That's going to be h squared to some power. Well, h squared to the 7th power would give me h to the 14th. So that means that I want r to be 7. So from this I see that r is 7. Of course, we can tell that n is 15. And then x is 2. And y is negative h squared. So I'm just going to fill in this term for h to the 14th. All right, so I'm going to fill all of these into this right here. So we've got n is 15, so I've got 15c7, and then x to the 15 minus 7, and then y, but our x is 2, and then y is negative h squared, and it's to the r, which is 7. So all I have to do to get the coefficient here is, first of all, get this. Now, I'm going to use my calculator to get this. We talked about how to use your calculator last time. And so I'm going to use my calculator and find NCR. And so 15 and 7. So this constant right here, my calculator says, is 6,435. Now I'm going to multiply that by 2 to the 8th power. 2 to the 8th power is 256. And then I have my negative h squared to the 7. That's going to be negative h to the 14. All I really need from this is the negative sign, and then I need to multiply these, because all we're looking for is the coefficient of h14. So if I take the 6,435 and multiply that by the 256, then my coefficient is negative 164,7360. So negative 1,647,360. This is the coefficient of the h to the 14th term in that binomial expansion. This is how you would get that. So this is an entirely different problem right here. We'll kind of separate that for you.